Okay, now moving to the views of really manufacturers. Now it's really my immense pleasure to introduce Jason Yan, Senior Product Marketing Manager at LONGi. Jason has 6 years in photovoltaic R&D experience in photovoltaic R&D department with new materials and product developments. Today he's going to talk about reliable bifacial modules for better LCOE from 156.75 size to 182 M, which is M10, for which LONGi has always been on the forefront in terms of promotion. So, Jason, the virtual conference floor is yours.
All right. Thank you for our introduction. Hello, everyone. It's good to see you. I think it's good afternoon. So, I'm Jason Yan. And LONGi, I'm a product marketing manager. So probably I will need to share my screen now. All right, here we go. So today I'm very honored to give a speech here. So my topic is about a reliable bifacial model for better LCOE. My presentation will include 3 parts. And the first part is about the significance of developing reliable bifacial model. This part I will talk why we need to develop a bifacial model. And then the second part is about the developing direction of the reliable bifacial model. Let's tell us how to develop the reliable bifacial model. And in the third part, I will show some real field data and some application of the bifacial model. So I think let's start. The first part is the significance of developing a reliable bifacial model. So basically, first of all, why we want to develop the reliable bifacial model. So our customer mainly cares about the I think it's always the profit. The higher profit, the higher the better. So the high profit means lower LCOE. When we look at the system design requirements for the models, the 3 important factors is about the sustainable and reliable and economic. So for the sustainable, we want our model have a higher energy yield, so such as we can adopt bifacial technology and some low irradiance performance and better LID and LETID performance. And for the reliability, we want the operation and maintenance security. That's required as the model is OEM friendly and makes long-term stability and the mechanical electrical safety. So the bifacial model always meets the requirement. And lastly, we want our models economic. So we want to have a lower capex. The bifacial model may have a higher efficiency, and when it has a reasonable electrical design and a structure design, it will have a lower both cost. So reliable bifacial model is developed to mainly reduce to the LCOE of the power plants. And the core of reducing the LCOE for power plants, I think, is to consider comprehensively the reliability of the power system and the models and energy yield. So, and therefore, it's not correct that the bigger model size, the better. Basically, the being reliable is the foundation, is the basic, and being economic is the target we want to get for a lower LCOE. So I will talk about how we can develop the high value bifacial model in the second part. Basically, this is a brief introduction of the bifacial model. I think previously has introduced, so I will give a quick introduction. So the bifacial tech means the more energy can generate by scattered light and reflected light which will bring more power and bring more value to our customer and get a lower LCOE. And also, in terms of cell technology, we want our bifacial model have a low degradation. So basically, there is a significant LID problem with conversion of PERC cells. So so LONGi, we resolve the LID problem by LIR technology and gallium doped wafer, and we optimize the hydrogen passivation process to mitigate the LETID. We have tested a lot of models. I think the LID and the LETID performance and the different third party, and the figure shows that all for different cells, for different technology, for the bifacial and the monofacial, all of them showed good results. The degradation is less than 1%, which is pretty good. And also in the material selection, we want to ensure our bifacial model has a lower PID. So we can choose the appropriate PLE material to control the surface polarization of PID defect. This figure is just a basic bifacial program model PID mechanism. Maybe you can check in the reference in detail. I will not talk in detail here. And LONGi, we think bifacial model design with a frame is most reliable because when you mounting a ground hose, when you have a frame, it's easy for transport and installation, and the models can be electrical grounded. And also, if you have a frame, that means you have a higher loading performance. The static loading can easily reach 5,400 per, and it means high protection for the model. And also, we have unique no shading design and C-side for frame. That design will give us, I think, is 0.6% higher energy yield than the normal frame design. So basically, the bifacial model with frame can decrease the model breakage rating during transportation and installation, and also it can give us higher energy yield. And now I think bifacial model with frame has become the mainstream technology by LONGi's promotion. And talk about the model in terms of the model size. So for the current existing capacity, we have insights on the model size. Actually, in the second half year of 2018, different size of spec mono wafer emerged, and we think the M6 spec, which the size is 166 millimeter, is based on the analysis of current cell and model capability and the reform cost, and also the supply of glass is also considered. So our M6 product is suitable for residential rooftop, C&I, and utility scale. That's a full scenario product. And based because our promotion, so the shipment of our HAMR 4 based on M6 wafer, is over 20 gigawatts. That's amazing data. And for the new, I think for the new build capacity, so that means we can build a larger size model, and we think the M10, which the size is 182 wafer size, was the optimal size for the bifacial model, because we did a lot of thorough analysis on model manufacturing and deployment process, and optimum model dimension is determined, and the corresponding wafer and cell size of 182 millimeter is deduced. We think the future innovation should focus back on the improvement of efficiency and power generation. And talking about the size also, our R&D is very careful, very cautious about the model design. So we think the size should be designed carefully. Increase in model size will increase the stress of material, especially in model width. And in the left-hand side figure, you can see when the model width and the length increase, and the risk of mechanical loading will increase, and the frame stress will also increase. So we have tested, I think, three different stress, two different stress and deformation for two different size model, and you can see clearly that if the model width increase to 3003 millimeters, the deformation will increase 40%, and the frame stress will increase 30% to 70%. That means high risk of mechanical loading failure. If you want to get, if you want to pass the nominal IEC, I think 5,400 par, you need to make the frame much thicker. That means a lot of cost in the model. And one key factor for the bifacial model, I think for the optimal size, is shipment container, because the landscape package is widely used and verified for many years in the shipment. It's mature and reliable. And 182 millimeters wafer size is the optimal size for the delivering high value to customer. If we can see the 40, I think the 40 high square shipment container, the door height is around 25 and 70. So if we deduce 100 margin and minus the pallet, and then we can get a model width is around 1130. If we use the traditional 6-row design, that means the wafer size is 182 millimeters. If you want to design larger wafer size, probably maybe for example, the 210, that means you need to change the package model. That this is the traditional landscape, and if you have a larger wafer size, you may change to the, I think is a tiered, is a flat, laying flat. The model is laying flat, or you can also change to the portrait model. So both of these two models have the risk. We have some data in the falling kinetic energy and the shock energy and the frame stress. We test all three data for them, and you can see the landscape is the optimal package model. And when you change to tiled or portrait model, the risk of falling down or shock energy or frame stress will goes up quickly. And for the bifacial model, because you need to control the modern current to a reasonable data. We think the modern current is not the bigger the better. It's important to consider the balance of economic and reliability. And we did analysis on the two different modern current model. If you can see in the figure, if we have the 40 amps of current, and for the cell efficiency is 20.76%, and the theoretical power is 541, and the actual power actually is about 540. So if we increase the motor current to 18.4 amps, and with the same cell efficiency, that's also the theoretical power is higher, is around, I think, 552. but the actual motor power is only 543. So the power loss is higher when the motor current is higher. And another opinion about the structure design, and we think the dual glass is better than transparent backsheet in terms of the four direction. So first of all, in material side, we think the glass is inorganic, and in transparent backsheet is polymer containing various organic additives. So glass is better than transparent backsheet. And for the reliability, and transparent backsheet, in R&D we did a lot of work in the transparent backsheet. Some of them exhibits yellowing, delamination, cracking failures in different tests, maybe ADH, UV, and PCT tests. And you can see in the right-hand side a different failure model for the transparent backsheet. And for the mechanical loading property, normally the symmetrical structure of the dual glass makes it better than a transparent backsheet structure. And also in the course, the dual glass contains 2 millimeters plus 2 millimeters glass, and the transparent backsheet contains 3.2 millimeter glass plus backsheet. So nowadays I think the cost is almost the same. So these slides are short summary for the development direction for the reliable bifacial model. So based on the optimizing on cell process, I think model design and BOM selection and deployment, higher reliable and optimal bifacial model were developed by LONGi. I just talked them previously. For example, in the model design, we need a reasonable electric design and a structure design. And for the BOM selection, we want a POE and dual glass with frame enables high reliability. And for the optimal size, we think M6 is the optimal size for the existing production line, and M10 is optimal size for a new production line. All right, so in the third part, I will talk about the application of a reliable bifacial model. Basically, in 2016, we started the R&D on the bifacial model, and we launched our first generation HAMO 2 bifacial model in 2017, the SNAC. So our first bifacial project is in December 2017. And I think while bifacial accounts for about 20% of market share in 2020 industry-wide, so over 40% of current LONGi's model shipment are bifacial. And we think the bifacial market share will still goes up, yeah, and will dominate in the market. So this is shows LONGi is a model manufacturer with the largest shipment over 10 gigawatts bifacial model over the world. So in Europe, in China and USA, we all have the bifacial model cases, and that's a real customer case. And we want we want our bifacial model most reliable. So we did a lot of threshold reliable tests to develop the bifacial model. For example, we did 304 times IEC standard for the bifacial model and compared with monofacial model. So our products both, I think, both showed a good performance. The degradation is less than 3%, even in 3 times IEC standard test. That's also amazing data. And also the bifacial model for our HAMO 4 is economics. So when we compare our 540 watts product compared with 595 watts products when we use the 120 meters rack, and the HAMR 5 can save both costs about 0.15 cents per watt. We calculated that in the Middle East use 2P fixed rack. Probably mainly the BL7 is contributed by the mounts and the foundation and the cables. And I think it has showed previously, we built the bifacial model with the best backability, and we have built a lot of pilot projects over the world, such as Saudi Arabia and India and China and USA. So all of these showed a real bifacial gain for the different albedo, the different ground surface, and for the different tracker, different racker. So in the next slides, I will show the real field data in detail. First one is we did a real field test in Chennai, India. I think it's also showed by the TV guys. So our project was in Chennai, India, and 2 models for each type. We test the monofacial PERC and bifacial PERC, and also the N-type bifacial PERC. So the bifacial gain actually was 19.3% in the white ground albedo surface. So the albedo is about 80% for the white grabber for LONGi's bifacial model. And another pilot project, I think, is in Saudi Arabia, and also the 2 models for each type, bifacial model and monofacial model. The clearance is about 1 meters, and the bifacial gain was 11.4% in sand ground surface, which the albedo is around 35%. This figure is we test the bifacial gain from September 2018 to July 28 for last year, for 1 year, for whole year. The average gain is 11.4%. And we also found an interesting thing is that we also have the data about the scatter ratio and the bifacial gain. You can see in the right-hand side figure, it shows that when the scatter ratio is higher, the bifacial gain is also higher. So that means the higher scatter ratio and the higher bifacial gain. And then we also did the real field test in Davis, US by PVL. I think in the PVL 2020 workshop also showed the data. Actually, the PVL test for different companies. I think our model shows the best bifacial gain for 2 different. Sorry. For different, I think it's ground. For example, if the grass albedo is 21%, the bifacial gain is about 7.48%, and if we use the white albedo, the albedo is 45%, and the bifacial gain is 11.44%. And also we did a pilot project in Livermore, USA by ITC. So the project was in Livermore and California, the 6 models for each type, and the bifacial gain was 8.3% in gray grabber. The ground albedo is about 21.4%, and the data I think we test around 1 month data. and the power generation, and we collected the power generation in a sunny day. It was found that so the bifacial perk gain is higher when it's, I think it's the morning or afternoon, and when in the noon the bifacial gain is lower. And also we cooperated with Nextracker. We have the field test in Fremont, USA, and the bifacial gain for both full cell and half cell models are bigger than 8%. The grass albedo is 20%. I think this data is very consistent with the previous data. The bifacial gain is around 80.3%. That means the data is very, very close. And lastly, it shows the cell efficiency of the bifacial model. So we have the PERC cell efficient record, which is 24.06%. And for the mass production, actually the average PERC cell efficiency, and we can achieve about 23.18%, which is pretty close to the theoretical cell efficiency, 24%. We think there is still a lot of room to increase the efficiency, per cell efficiency. And for the summary, we think bifacial model has been an effective approach to reduce LCOE and deliver high value to customer. And the size of P model is not always the bigger the better. It's necessary to comprehensively consider all aspects of model manufacturing process, as well as model deployment process and transportation and long-term reliability, and to evaluate associated risk. So economic and reliable and high-end yield are the basic design direction for the bifacial model. That's all. Thank you.
Okay, thank you very much for this informative presentation, Jason. There are a couple of questions what about the vulnerability towards the hail damage when front glass gets thinner in dual glass configuration?
Pardon me?
So, when you are using a dual glass, you have a thinner glass, right? Relatively compared to 3.2 mm glass of glass backsheet configuration. So what would be the chances of module getting into danger with hailstorm? Hail.
You mean the 2 millimeters glass plus 2 millimeter glass versus the 3.2 millimeter glass, right?
Mm-hmm.
So what do you want to get? What's your point?
When you have a hailstorm, what would be the chances of having the mechanical stability or kind of glass breaking when compared to 3.2 mm?
Sorry, I think the connection is not good. I didn't get the question very clearly.
Okay.
Yeah, maybe you can switch another question. I will check the message in the chat room.
Chat group. Yeah, I think that's good. That's really nice. So, how much is the difference in fill factor between the monofacial and bifacial? Can you comment on that?
You mean what kind of property?
Fill factor.
Field factor.
Yeah, fill factor, FF.
Oh, fill factor, right. So for the bifacial model and the monofacial model, right? So basically, I think it's pretty close. I think it's around, I think it's around 79 Yeah, 79%. So not much difference. Yeah, for the fear factor.
Okay. And of course, I think, probably it's available in datasheet, but I think it's nice to say, like, there was a question like, what is the year module degradation factor? So what is the degradation per year for your bifacial as a spec?
You mean, so basically for our bifacial mode, the first year, the warranty is less than 2% for the degradation. And in the second year, from second year to the, I think the 25 years, the degradation is about 0.45%.
Okay. Okay, so thank you, Jason, for this valuable insight, and I think you have showed very nice results showing the bifacial gains. So there are a few more questions in the chat room, and probably you can also answer a few questions there.
All right, so yeah, I will answer the question in the chat room. I'm sorry that the first question is the connection. Yeah.
Okay, no problem, no problem. Yeah. So thank you very much.
Okay, thank you guys.